Hi guys, welcome to my channel. I'm Abhishek. I'm a techie with 3 years of experience in full stack development and have a great passion for teaching. So Newton School gave me an opportunity to educate you all in different techs. And basically you all might be aware of Newton School. It's a platform which helps you to build a career in tech. Whether you are experienced or a fresher doesn't matter. It's for everyone. They will teach you for a period of 6 months, then will refer you to a lot of jobs until you get placed with 5 lakhs or more. You don't have to pay anything. And they have launched a product. You can see the name on the screen, Launchpad. So Launchpad is basically a website which is totally free for learning, where there will be a lot of mentors, lot of codes, lot of quizzes, lot of assignment. Go sign up and enjoy the course. Hi guys. So today we'll be studying about Uh, this will be our first video in algorithm. We'll explore this topic more. So we'll study about asymptotic notations. We'll understand what asymptotic notations are, and this is the first video on it. We'll do a lot of practice question on it along with it, so you get a lot of idea. We'll cover a different kinds of question, in normal case, then you can see like in any type of program, how can you find out complexity. Okay, we'll cover several examples on them. So first let's try to understand the basics. So first video and second video will be mostly focused on the basics of these concepts. Okay, so once you are clear with the basics, then we can jump to the, like, what do you say, practicing few of the things. I'll be giving few problems, so you guys can practice together. Okay, and so on. We'll proceed. So the first thing that's important, what does the term mean, asymptotic notation? What does it mean? So let me start my annotate screen. What does it mean? So see, to be very simple, it's nothing. The term is very simple. There are three kind of notations that we use to analyze our program. Okay, one is called big O notation, one is called big theta notation, one is called big omega notations. Okay, what these notations will tell you? These notations, with the help of this notation, you can analyze that how will your program behave if your input goes on increasing. Like let's suppose you increase the input to infinity. How will your program behave? So basically, if the input varies, how will our program time varies? How much time it takes to run? So we'll discuss about that. Okay, so this lecture is just focus on time complexity. Next lecture will be focused on space complexity and some more topics. So these three will help us to analyze the time of an algorithm. Okay, so like see, so we'll understand one by one. So see, ON, what will ON do? ON will help you to identify the worst case. We'll understand what are worst case, but it will help you to identify the worst case. This is called theta, and the symbol is this. Write O, put a N, theta, and this N. Okay, so this is for average case, and this is for best case, omega. Okay, omega N. So this is for best case. Now what do you mean by these? Worst case, best case, average case. Okay, so first let's go one by one. So let me turn it off. Let's go one by one. Okay, so this is big O notation. Okay, I wrote in extra O, sorry about that. So big, like I told you, what will big O notation actually do? Big O notation will give you the upper bound for the runtime of an algorithm. Upper bound means what is the maximum time an algorithm will take to run. Okay, so it is for the maximum time. Big theta, it is basically for the average time. Okay, big theta is for the average case. So big theta focus on the average case, and then the third is big omega. So big omega will mostly focus on the best case. Means what is the fastest way? What is the fastest time this algorithm can run? So the terms are confusing. What they mean by fastest time, average time, and slowest time. Someone can get confused that algorithm will always run in one time. So there can be some confusion. So let's try to understand it with a very simple example so things will be much clearer to you. Okay, let me start it. So let's suppose we have an array. Okay, I'm talking about linear search. In case if you guys don't understand, don't remember linear search, not a problem. The point is, I have an array with few elements. Okay, let's suppose n elements. Okay, now I have to search, like let's suppose I have an x. I have to search if this x is present in this array or not. That is the whole problem. So what is the simplest way to do? First I'll compare x with the first number, then I'll compare x with the second number, third number, fourth number, fifth number, sixth number, seventh number, and so on. Whenever it is found, I can stop. Okay, or you can keep on comparing, or after a loop you can print it, depending on your solution. Okay, let's try to understand all the solution. So remember, we used to talk about omega n. So what is omega and what does this n means? Okay, so basically this means the best case. Best case means like what is the best case for our program to run. So let's think about the best case. Okay, so suppose the value of x is 10. So what will happen? When it matches the first number, there is a match. That means I cannot have a situation better than this. I have an array and I am trying to match an element in the array. Now you see the first element you matched, that is a perfect match. Okay, so this, like, how many steps did you need to match it? Just one step. So what it will be? It will be 1. Omega 1. That means this is the minimum time that our program can take to, what do you say, to execute this program. Okay, so see the difference clearly. Basically, I counted out what is the best possible case for this algorithm. Okay, to find 10 in this array, what is the best possible way? Best possible scenario can be 10 is at the first position, and that is, so the complexity. So like, what do you say? The best case is 1. Okay, let's talk about the worst case later, and we'll understand worst case and average case in a while. I'm sorry. Let's talk about the worst case now. We'll deal with the average case a little later. So what do we mean by worst case? Let's imagine a worst case here. Let's suppose we are searching for 70. So now let's suppose if we are searching for 70, so what will happen? 70 will not match the first one, not match the second one, not match the third one, so on. It will go on and match the last one, right? So means, what is the worst case possible here? Like this, I have to entirely iterate the whole array and go to the last element. So suppose there are n elements here. So how many times you have to go? You have to iterate through all the n elements, right? That is why the worst case will be O n. So see, the symbol is very clear. For the worst case, we use O n, big O. Okay, this is called big O notation. For the worst case, whenever you have to find out the worst case, you will use the symbol O. Whenever you have to find out the best case, you will use the symbol of omega. Okay, and what is average case? Average case we generally don't use in every type of problem. We generally use average case only when the best case and the worst case are equal. But any case, anyway, you can find out the average case. The average case will be O n by 2. Sorry, theta n by 2. Now, since our average case is theta n by 2, you know. If you don't know, we'll study about this. Theta n by 2 will be equivalent to theta. Okay, why this came, if you don't understand why this happened, we'll get an idea about this later. But let's be very clear about it. What is the difference between these notations? Whenever you have to find the best case, which we rarely find, we generally don't look over the best case. We mostly look over the worst case. But anyway, if we have to find over the best case, we'll use a symbol of omega and see what is the best way to solve this problem. Okay, how many steps do you need to it? We just need one step. Okay, now for 70, how many steps you need? You can count like 1, 2, 3, 4, 5, 6, 7. Okay, that is like we are talking about the worst case. 7, but let's suppose it's n, because let's suppose there are some dots and there are a lot of elements in between. So now the thing is, now there are 70 elements. For 70, I have to go from the start to end. That means I have to iterate the whole array. So if there are n elements, what will be the worst case? N. That means there is a possibility my last element will match, right? And average case, you are clear, right? If the both are equal, then we'll work over the average case. So that's all. Nothing to be like, what do you say? It's not a difficult topic. You just have to analyze your loop. Okay, how your loop is behaving, how much time your loop is running. Okay, we'll go through several examples, but that's the difference. Big omega for the best case, O notation for the worst case, and theta notation for the average case. And these are the simple. Okay, the most among them will is use worst case, the least use is best case. Okay, because we really, like, if I am writing an algorithm, I will not be concerned like what is the maximum speed my algorithm, like what is the best case possible. Okay, we generally talk about the worst case, because if there is a worst case, my program will take so much time. So we generally deal in worst case, not in best case. Okay. Okay, guys, that was the thing about the omega notations. Now based on this, there are different things that are possible. So first, the next topic we'll study is space complexity, just like the time complexity, and then we'll study more about the worst case, because that is the thing which you will be using for almost most of the algorithm. So now, how is the algorithm better? Like, what will you say? So algorithm is considered better if the worst case complexity is as least as possible. Okay. So if I tell you to optimize your code, there is a high chance you should reduce the complexity of the code. That is the worst case. Okay. Okay. So we'll discuss those topics. Anyway, guys, that's all from my side for today, and we'll continue with these topics from now. And also at the end, don't forget to like and subscribe my channel and the bell icon, guys. Don't forget it. I'll keep making the videos and you will keep getting daily updates. Okay. And also check out our product, which is called Launchpad. So Launchpad, guys, you can sign up there and access all our course, right? Even the course is present on YouTube, but on Launchpad it's much more organized with quizzes and assignment. Okay, guys. Bye bye. I'll see you later.